Assalamu alaikum students and dear learners. This is Tishamila, Assistant Professor, Department of Computer Science, Vajiha Women's College, Kayalpatnam, which is affiliated to Manan Maniam Sundarnar University. Learners, today we are going to see the topic job scheduling algorithms in operating system, and this is very important topic as far as the university point of view exams. Also it will be helpful for your competitive exam also. So there are many more algorithms are available. Today we will see FCFS algorithm. What is FCFS? That is first come first served algorithm. So the jobs will be get processed in which the order it will get into the queue. That is called it as the FCFS algorithm. And there are two modes are available which are already familiar in OS concepts, that is primitive and non-primitive. And this algorithm speaks about the non-primitive mode. What is non-primitive actually? So the process, if one process is getting into the queue and one process in the running mode, the other process has to wait until the previous process will complete. For example, the P1 is running and it will take 10 minutes to complete it. So the other process, P2, P3, P4, etc., many processes will be available. They should wait in the queue. They will not come and get disturbs the first process called P1 process. So all the process should wait until the other process should complete. For example, take P2 here. The process will P2 will take a time, it will take 5 minutes to complete it, to complete its process or complete its task. So the other process has to wait. It should not disturb the process P2. This is called it as a non-primitive mode. So there will be the no disturbance until this process has complete its job or completes its task. And we are going to see this with the help of example. And it is given as 5 processes are given, P1, P2, P3, P4, P5, and the arrival time is also given. 0 for the first process P1, it is arriving at the time 0, P2 will arriving at time 0, P3 is arriving at 2 milliseconds, and P4 5 milliseconds, and P5 10 milliseconds. And the last column is CPU burst time. For example, P1 process is arriving at time 0. It will take 10 minutes to complete the process. And take process P3, it is arriving at 2 minutes, 2 milliseconds, and it will complete the burst. It will complete its process by 3 seconds. So it will take 3 seconds or 3 milliseconds to complete its process. Take P5, it is arriving time is 10 milliseconds. So at 10 milliseconds only, it will enter into the queue and it will take 2 minutes to complete it. We are going to solve this problem in FCFS mode. We'll see the Gantt chart here. Gantt chart is a chart representation and it will give the time division of all the process. At the time 0, take time 0. So what is the arrival time 0? In the arrival time 0, which is the process getting inside, P1 and P2 is getting inside. But which is in the first come first served manner, P1 is getting into the queue first. So P1 will get the process time. So P1 at the arrival time 0, P1 is getting started and it will take 10 milliseconds to complete it. So 0 to 10, that will be the process P1 allocated to P1. Then P1 got over. Then see P2. And P2 is arriving time is also 0. And because of the first come first manner, P1 get into the first. P1 completes its process first and P2 comes next. And P2, if you see the CPU burst time, it is 5. So in the next to the Gantt chart, we should write P2. So 10 plus 5, 15. Next P3. P3's completion time, the CPU burst time is 3. So P3, 15 plus 3, 18. And P4, it will take 20 milliseconds. So P4, 20 plus 18, 38. And P5 will take only 2 milliseconds. So P5, we should write 38 plus 2, 40. And we have to give the calculation. Our purpose is we have to calculate the average waiting time of all the process. First write process and given arrival time and given CPU burst time. They may call it as CPU burst time or execution time. You can call it by many names. And see the CT. CT is nothing but completion time. For the process P1, what is the completion time is 10. For the process P2, the P2 is getting completed by 15 milliseconds. So 15. In this way, you have to write the completion time for all the 5 processes. Then turnaround time. How to calculate the turnaround time? TAT stands for turnaround time. Turnaround time equal to, formula is completion time minus arrival time. So that is given there. Completion time minus arrival time. We have to calculate it. And waiting time, once again, the formula for waiting time is turnaround time minus CPU burst time. If you calculate it, and you'll have the values like this. Then our purposes, we have to calculate the average waiting time. Average waiting time equal to, add the last column of all the process and divide by 5, because we have the 5 process, divide by 5. We'll get the value 12.8 milliseconds. So in this way, we have to calculate the average waiting time in the FCFS job scheduling algorithm. Here we have to keep two things in our mind. One is, this is always work in the non-primitive mode. What is non-primitive mode? Once again, so P1 has to complete its process, then P2 will enter. P2 will complete its process, then P3 will enter. So none of the process should disturb the other process until it gets completed. So the process P1 has to complete, then P2 will enter, then P3 will enter. In this way, it has to be done. And what is the formula for turnaround time? Turnaround time equal to completion time minus arrival time, and waiting time equal to turnaround time minus burst time. Thank you for listening, and we will see you in, we hope we'll meet you in the next video. Thank you.